elements in steel. That the alloying element, each alloying element is effect on steel. This helps us to increase the hardenability or decrease the hardenability, or increase the ductility or decrease the ductility. And also the effect of mechanical properties of the steel, like stainless steel or carbon steel, alloy steel. The difference type or the difference effect is coming from the alloying element. Firstly, carbon is the major effect of steel property. Carbon increase the hardenability, carbon increase the hardness, tensile strength, yield strength, and this increasing of mechanical properties and the tensile strength is coming from the percentage of the carbon itself. Low carbon is mean 0.03 and 0.15. Medium carbon 0.2 or 0.35, and the maximum of carbon in our steel is 0.35 to define the good tensile strength of the carbon or the steel. And also the carbon affecting the steel for the ductility and weldability. The weldability or ductility decrease if the carbon percent is high, or the ductility and weldability increase if the carbon percent is low. Manganese contact with the carbon and help the carbon for the increase the strength and also hardness, but less than the carbon for efficiency, for the effect of steel. The carbon is the most effective, but the manganese can help the carbon to increase the strength and yield strength. Phosphor, the increase of phosphor can increase the strength also and the hardness, but not like manganese or carbon. Sulfur, by increasing sulfur, weldability will decrease, ductility will decrease, and notch impact toughness especially must be performed if the sulfur high content. But the sulfur added to our steel composition to improve the machinability. Silicon is an important element in our steel. The main effect is de-oxidizer. De-oxidizer used in steel making, and the kill the carbon steel. It means the silicon is percentages effect and very high. Not very high. It's mean high percentage, but the increase of percentage of silicon can affect and the strength, or like increasing rolling, increase hardness. In low carbon content, we need the silicon to de-oxidize the steel. Copper, we need the copper for hot working steel, but is not likely or familiar with the welding, but does not seriously affect arc or oxyacetylene welding. Copper can be determined to surface quality. We need a good surface, meaning you must add some percentage of copper in your stick. And also the percentage of copper in your steel can be add properties like corrosion resistance, but atmospheric corrosion resistance if you amount exceed the percent of copper 0.2%. Lead Lead uh, lead is a good element, but we added to carbon steel or alloy steel two means of mechanical dis dispersion during pouring to improve the machinability. Boron and also to fully kill the steel to improve hardenability and the percentage of or range of percent in boron in the steel 0.0005 to 0.003%. Chromium is an important element in alloying with the alloying element for the alloy steel and the stainless steel. The chromium increase the hardenability, oxidation resistance, corrosion resistance, increase hardenability, may for increase the mechanical properties or the hardenability or the tensile strength of the metal is like carbon or more than carbon efficiency. Nickel. Nickel is a ferrite strengthener, increase the strength, toughness, and also increase the nickel percent, this means increase the hardenability and the impact strength of steel, and also can help the chrome at the temperature from 500 to 800 to avoid the chromium carbide. Molybdenum. Molybdenum increase the hardenability, and molybdenum may produce secondary hardening during the tempering or quenched steel. Aluminium deoxidizer can control austenite grain growth in reheated steel and is therefore added for control grain size. Aluminium is the most effective alloy in controlling grain growth prior to quenching. Zirconium. Zirconium, if we add zirconium to our steel, add to kill the high strength low alloy steel, and zirconium also when we add the zirconium we produce the stabilized material and effective ductility and improving toughness also. Niobium. Niobium increase the yield strength. Niobium does increase in the yield strength, and also niobium improve the stabilized material if we add it to stainless steel also. Vanadium increase the yield strength and tensile strength of carbon steel, and this the good alloying element, and this controlled the ferrite grain size is refined, and there is a corresponding increase in toughness. Now we talk about already we talk about the alloying element and the effective in the steel. Most of the element is effective in the tensile strength, and yield strength, and the resistive corrosion, surface corrosion, and stabilized material. You can or we'll discuss in the next session how to evaluate your material good or need some elements to add.